In this video, we'll continue with exercises of implicit differentiation, looking at number 13 and 15 here. In 13, we have the sine of x is equal to x times 1 plus the tangent of y. And there may be different ways of going about this. I think that I would multiply out the right side and take the derivative of that. Now, I'm not sure exactly what that's going to buy me. I still will need to use the product rule, but at least the product rule will be a little bit simpler. So I've simplified before taking the derivative of both sides. Now I'm going to find the derivative of both sides with respect to x. On the left side, the derivative of sine x is simply cosine of x. On the right side, the derivative of x is 1. And the only real challenging part of this problem then is the derivative of the product x times tangent of y. And so we have a product rule, but there's no minus signs, which makes it easier. So it's the first times the derivative of the second. So that'll be x times the tangent of y. The derivative of tangent is secant square, and we'll treat this like a chain rule, leave the inside alone, and then multiply by the derivative of the inside. So we have secant square y, and then times y prime. Now I'm going to put the first y in parentheses just to highlight the fact that the y prime is not part of the secant square of y. It's y prime times the secant square of y. So again, that was just the first times the derivative of the second plus the second now, tangent of y, times the derivative of the first. Derivative of x is just 1, and so that doesn't change it at all. So what I'm going to do then is simplify just a bit, but I want to isolate the y prime term, and I only have 1 on the right side. So I'll subtract 1 and tangent of y from both sides. So the left side will now be cosine of x minus 1 minus tangent of y, and that will equal x times the secant square of y times y prime, and I'll divide by x secant square of y to isolate the y prime on the right, and I will get cosine of x minus 1 minus tangent of y, all divided by x secant square of y. And that's going to do it. Cosine of x minus 1 minus tan y over x times secant square of y. Finally, we'll look at number 15. And that says y is equal to sine of xy. There's no simplifying to be done before we begin. So we'll start by taking the derivative of both sides with respect to x. So the only challenging part of this will be taking the derivative of sine of a product xy. So that's going to involve the chain rule and a product rule inside the chain rule, along with implicit differentiation. So there's not a lot of pieces to this puzzle, but it is a challenge nevertheless. On the left side, the derivative with respect to x of y is just y prime. And on the right side, we have the derivative of sine of xy. So the derivative of sine, taking the derivative of the outside, is just cosine. And we leave the inside alone, xy. So first part done. We took the derivative of the outside, leave the inside alone. Now times the derivative of the inside. So we want to multiply cosine xy by the derivative of x times y. So I want to put this in parentheses because we have to multiply by the whole unit. The derivative of xy, and actually I'm going to write this in this way just to show that you can do this stuff in steps here. You don't have to do it all at one time and get lost in the process. So we have the cosine xy times the derivative of xy. Now we can do that in the next step. So y prime is equal to cosine of xy, then times the quantity, first times the derivative of the second, xy prime, plus the second, y, times the derivative of the first, which is 1, and that does it. Now we have some simplifying to do. And we'll need to distribute the cosine xy to both of those terms. So we have xy prime cosine of xy plus y cosine of xy. I'll need to combine the y prime terms together on the left. Then factor out a y prime from the left. Then divide both sides by 1 minus x cosine of xy, leaving me with y cosine xy divided by 1 minus x cosine xy. And that does it.